Now, the key to simplifying expressions is you can only simplify things if the factors are directly or exactly the same. So going back to numbers at the beginning here, remember when I did something like 4 divided by 6? You can make this 2/3 because you're good with numbers. But what we're going to do is we're going to write 4 as 2 times 2. I mean, when we get to the algebra part, our algebraic expression, we're going to factor. We're going to write 6 as 2 times 3. And then we're going to simplify those 2's. And that works when you're multiplying. Notice that it doesn't work when you're multiplying. Okay? For example, if I have 3 plus 3 divided by 3, it doesn't work if we're adding. I cannot simplify these 3's. If I did, what would I get as my answer? Just 3? But what is this? Yeah, 3 over 1. Because technically when you simplify, 2 1's are left. So maybe this should equal 4. But you know that 6 divided by 3 is equal to 2. So the point that I'm trying to make here is that whenever things are added together, like in A, these 3 things are added together, they will get grouped together. These 2 things are subtracted, they will get grouped together. On the bottom here we have 3 things that are added, and then 2 things that are added. So currently, those are our groupings. Those are our factors. And the only way we can simplify factors is if they're identical. But currently, none of them are identical. So what we'll always need to do is factor everything completely. Once things are factored completely, maybe then there'll be some identical stuff. So x squared plus 9x plus 20. Can we factor that? X and x, 5 and 4, plus plus. 2x squared plus 6x minus 8. There's a common factor first, so do that first, leaving you with x squared plus 3x minus 4. X squared minus 1, can you factor that? Difference of squares. And 3x plus 15, common factor of 3. Are we done factoring completely? No. You can still factor this one more on the bottom, but before we do that, can you see that we do have a factor that's identical now? So I may as well cancel that out to save me a little bit of space. Okay? Now, whenever I'm working on these questions, if you're doing this in your notes, what's a good idea? Leave a little bit of space when you go from one line to the next. Otherwise, your fractions just look like big things piled on top of each other, and if you look at it later, you won't necessarily be able to follow what you were doing. So I leave a little bit of space, and now I'm going to rewrite what I have. I have x plus 4 over 2, and now I'm going to factor the bottom here. It's going to be x and x has to be plus 4 and minus 1. I rewrote everything except for those x plus 5's that I already simplified. Now that I factored the bottom again, is there other things that simplify? The x minus 1's will go away. The x plus 4's will go away. Again, I would leave a little bit of space and write my final answer. On the bottom, I'm left with 2 times 3, which is 6. On the top, I'm left with x plus 1. Okay. Now we're going to do some mental math practice. I want you to look at this in A. Okay? I'm going to pick x to be different numbers. You have to look at it and then put in that for x and calculate it as quick as you can. First number I'd like you to do is x is 11. It's 2. Good. That was quick. I'll do another one. How about x is 5?
2.
It's 1. Okay, you can't answer anymore because you're doing your mental math too quick. Let's try a tougher number. How about 17? 3. Okay, if you figured out the shortcut. Now look, what do I have up here? This is complicated, right? Putting in 17 here, you have to start with 17 squared. You're already stuck because you can't think of 289 quick enough. And then you got to add 19 times 7, which is like 133, 153. Oh, so big, right? But look, we simplified it. What does it simplify to? X plus 1 divided by 6. Plug in 17. 18 over 6, 3. Plug in 11. 12 over 6, 2. Okay? The reason we simplify is so we can do calculations quicker. Yeah, and then you show them this one, and then you don't tell them what it simplifies to. Okay, let's look at part B. Right? Step 1, we're going to rewrite this as multiplying. Are you okay if I factor out that common factor of 3 right away? And factor out the common factor of 3 on the what was on the top? Are you okay with doing 2 steps at once? Okay. Can you see that these 3's are identical? Now they're going to go away. Now let's factor everything. X minus 2 can't be factored. It's going to get grouped together. 3x minus 21 has a common factor of 3. Take it out, you'd be left with x minus 7. A trick in these questions, textbooks don't like to make questions that don't simplify, because that's the enjoyable part, crossing things out. So when you look at x squared minus 4x minus 21, there's usually a hint in the bottom of the question what one of the factors is going to be. I think that one of the factors is going to be x minus 7. Well, 2 numbers to multiply by to get 21, you can already probably assume it's going to be x minus 7 and x plus 3, and check it, and sure enough, it works. The bottom is a difference of squares. Oh, there's an x minus 2 on top. How nice that there becomes an x minus 2 on the bottom. Now we look, are there things that are identical? Yes. And we're left with x plus 3 on the top and 3x plus 2 on the bottom. So these ones that have a little bit more factoring to do are 7, 8, and 12. You'll notice that in the answer key, they always write all the values that weren't allowed, all the non-permissible values. If we had to do all the non-permissible values for this one, what are they? X can't equal 7, because then we divide by 0 here. Can equal 2. Can equal negative 2. Those are the places where you're dividing by 0 here. You have to remember, though, that this part right here, right, having a 0 on the top of a fraction is okay, except where did this come from? This highlighted part came from here, where you were dividing it originally. So that means that negative 3 is also a non-permissible value.
Do you have to do NPVs for every single one?
So unless it's asked for, if it just says simplify, I'm okay with you just simplifying it. You don't have to write the NPVs. But if it says what are the non-permissible values, and I'll be explicit on my test, I'll say what are the non-permissible values, then you'd have to state them.